Hello, students. So this lesson is going to be scientific notation. We're going to do more real-world problems with scientific notation. So just to practice review here, write each number in scientific notation. So we have the first one's a large number. Remember that first part of the scientific notation called the coefficient that has to be greater than or equal to 1 and less than 10. So we're going to move that decimal there. So it's going to be 6.032. You have to get all of these digits here, numbers, until you see just zeros. Okay, so this is 6.032 times power of 10. It's moved over. Here's 3, 6, so it's 8. Big number, positive exponent. All right, so this one, we're going to move that decimal over between the 6 and the 1. So 6.142. Looks like we've got 4 zeros, and then one more place is 5, and it is a small number, so negative exponent. All right, so today I'm using scientific notation in real-world situations so that I can understand how scientific notation is used in everyday life. I'll know I got it if I can analyze the given situation and use scientific notation correctly. Our essential question: how do I use scientific notation in real-world situations? So this you should already have, so make sure you do. This is the academic vocabulary for scientific notation. So let's just practice a few more. We've got the distance from the sun. We said that was going to be real world. So here is that number, 150 billion meters. So you've got to put that decimal over here between the 1 and the 5, very large number. So 1.5 times 10, and then count how many places it's moved over. 3, 6, 9, and then 2 more places, 11. Our next one is a small number, mass of average human cell. So this is going to go all the way over here. Let's see if I can count all those zeros. And we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can always zoom in. Maybe I'll do that. Make sure we got this right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Small number, negative exponent. So it's just going to be 1 times 10 to the negative 12. All right, let's do one more on the recording, then you can pause the video and do the other two. So you're going to go all the way over here, and that's going to be 3.7 or 3.474 times 10, and it's moved over 6 places. All right, another practice problem. The area of a piece of land is 4,951,000 square meters. How is this number of square meters written in scientific notation? First, it's a large number, so we're going to eliminate these two that have negative exponents. Gone. Now we're going to move it over between the 4 and the 9. So look at the choices that we have now. That's what we need, but look at this. That's a comma. That's not correct. Now let's make sure this exponent is correct. We moved over 3, 6. That is correct. All right, just a couple more here. I'm going to go down here. So you'll have a quiz, and just want to make sure you understand how to do this type of problem. So this well, it says what is it in each number in scientific notation. It's one of those click and drag problems. Now this one is going to be a negative exponent. You're going to move it over here between the 3 and the 7. So it's 3.7. which these are all 3.7, but it's either going to be -7 or -4 because it's a small number. Just look at how many places it's moved over. There's only 4, so it's going to be this one here. This goes here. You change the pen color for the next one. So large number, so it's going to be either to the 4th power or 5th power. So it's moved over 4 places. So it is going to be this one. Another type of problem. So it's actually same thing. There's only one example on here. So you've got a very large number. Okay, these are all positive exponents, so that doesn't really help. But if we move it over here, it's got to be 1.35. So you can actually get rid of a couple or a few of the answers. This is not correct. Get rid of it. This is not correct. Get rid of it. This one's okay. This is not correct. Get rid of it. This is not correct. Get rid of it. This one's okay. Now let's figure out, is it to the 12th power or 14th power? So you're going to count the number of places it moves. There's 3, 6, 9, 12, and 2 more is 14. So it's this one. All right, last problem. Oh, we've already done this one on a previous video, but let's just have it on here since it's here. So we've got to move this over here. It's a small number. Those are all negative exponents, so it doesn't really help. So it's 1.65. That helps because this says 165. Nope. This says 16.5. Nope. This says 0.165. No. And then it's moved over 3 places, so that is correct. Times 10 to the -3rd. All right, just reach out to me if you have any questions.